Okay, so this we might get it all on this last video. This stuff is material for the final only. That's at least what the syllabus is supposed to say, and that you don't have to worry about this for exam three. Well, I'm assuming that's correct information, and but it does turn out on the final. So be careful about that. Okay, the pencil. The topic is called rational functions. Right, that's the general topic, and it is 3.5 in your book. 3.5 in your book, rational functions. But particularly, we want to talk about horizontal or vertical, both vertical and that's my sign for and, whether it is whether you've seen that before or not. I mean, I've done it before. Vertical and horizontal, and here's the vocabulary word that you haven't seen before, I'm quite sure, and that is they're called asymptotes. So let me just show you visually what they are, and then we'll do some problems with them, the usual. So let me show you just an example of a vertical asymptote. Let's say you have a graph that goes like here's the y-axis, the regular y-axis, the regular x-axis, and then there's an imaginary line over here that there's a line that goes that's parallel to the y-axis. So we're talking vertical. And your graph does whatever it does, and eventually it goes like this, right near the y-axis, but never right near the y equals what? Let's say this is y equals 5, right near a vertical line, but never actually touches it. That's a vertical asymptote. It's getting near a vertical line, getting closer and closer, but never actually touching it. The same exact thing for a horizontal one. So this was a picture, so to speak. You can get much better pictures in your book of a vertical asymptote. And here's a picture of a horizontal one of my lousy pictures. But here it is. Here's the x-axis. Here's the y-axis. There's a line, right? Let's say it would be y equals 3. This is x equals 5. That was not supposed to be 1, 2, 3, 4, 5. Let's say this is y equals 3. 1, 2, and 3. And this was y equals 5, x equals 5. This is y equals 3 right over here. So let's say this is y equals 3. What's an example of a horizontal asymptote? Something that's getting closer and closer and closer to that horizontal line, but never actually touches it. That's what the graph is doing, getting closer and closer to this horizontal line, but it never actually touches it. That's a horizontal asymptote, right? This is a horizontal asymptote, a crude picture, and this is a vertical asymptote, crude picture. Okay, that's just to show you what we mean by asymptotes. Now we're going to show you some problems. And we're starting out with the subject of horizontal asymptotes. I do not know if we're going to get vertical. I'm sorry, we're starting off this subject. I apologize, I'm rushing myself. Vertical asymptotes. And I do not know if we'll get to horizontal asymptotes on this video. We'll see, let's see. Okay, problem number 1. Let's say you have a function that says it's a rational function. After all, that was the title, rational functions. So this is asymptotes is a part of rational functions. So let's say you have f of x of a rational function. F of x is equal to 2 over x minus 3. And the question is, what is the vertical asymptote? Vertical asymptote, question mark. Here's what you do. You look at the denominator, set it up to 0, x minus 3 equals 0, solve for x. This is going to be a pretty straightforward, simple problem. X equals 3, and there's our answer. The vertical asymptote of this function is x equals 3. That is a vertical line. X equals 3 would be, using our picture up here, you would move over 1, 2, 3, vertical line, and then the asymptote. That's where the asymptote, meaning that's the line where the thing is getting closer and closer to. Okay, well, what about problem number 2? A little bit more complicated. What if we have, let's change the wording here, g of x, let's change the letter, g of x is equal to x minus 4 over 3x squared plus 5x minus 2. Okay, and again, the question is, what about vertical asymptotes? There may be more than one. Vertical asymptotes or asymptotes. What do? Here's what you do. You've got to set this up equal to 0 and solve it. Let me call it scrap paper. As a matter of fact, I could have called this scrap paper as well until we got to the answer. Let me now move the paper because I don't want to miss out on some space here. And what are we supposed to do? This is what we do. We set up 3x squared plus 5x minus 2 equals 0 and treat it as the quadratic equation it is. Either you use the quadratic formula or solve it through factoring. I want to solve it through factoring. So if I solve it by factoring, and I'm just going to remind you about factoring. What do we do when you have the coefficient of x squared is higher than 1? Here's what we do. We multiply 3 times 2, which is equal to negative 6. Where did I get that from? 3 times negative 2, which is negative 6. Put the 5 underneath. Get the two numbers that when you multiply a times b equals negative 6 and a plus b is equal to 5. Those two numbers are positive 6 times negative 1 is negative 6. Positive 6 plus negative 1 is equal to 5. Those are the two numbers. What do I do with those two numbers? Separate 5x into 6x minus 1. 3x squared plus positive 6, so it's plus 6x minus 1x, I don't need the 1, as you all know, it's understood to be there, equals 0. Then, sorry about that, and then split it into 2 and get the GCF of this. The GCF here is 3x. 3x into x squared is x. 3x into 6x is positive 2. The x's cancel. Bring x plus 2 over here. Check out how to get from x plus 2 to negative x minus 2. The answer is through minus 1. Minus 1 times x is minus x. Minus 1 times 2 is negative 2. And here's our two pieces. It's going to be 3x and the minus 1 belong in their parentheses. One copy of x plus 2 belongs in their parentheses. What do? I set up 3x minus 1 equals 0. Plus 1 on both sides. And this becomes 3x equals 1. What is x? X is equal to 1/3. Here's one of my two vertical asymptotes. What's my other asymptote? I have enough room. This time I set up x plus 2 is equal to 0. Minus 2 on both sides. X equals minus 2. And here we go. There's my second isotope. Isotope 1, isotope 2, or vice versa. It doesn't matter what order they are. And those are my two vertical asymptotes. Okay, now problem number 3. I have enough room. I want to go upstairs a little bit. Problem number 3 is going to be very short. Just bear with me. Problem number 3. What about if f of x, if you're given f of x is equal to x squared plus 4, what's the vertical asymptote? What is the vertical asymptote? Not asymptote, asymptote. I'm sorry, thinking of chemistry. Okay, so set up x squared plus 4 equals 0. Minus 4 on both sides. X squared equals minus 4. Take the square root of x squared and the square root of negative 4. There we have it. This tells us everything we need to know. It's an imaginary number. It's going to be an imaginary number. Therefore, there is no vertical asymptote. That's the answer to this question. There is no vertical asymptote. That is your answer to this question. There is none. 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 Okay, that takes care of vertical asymptotes. The next video has got to be about horizontal ones. Okay, we go up here.